Good morning. I'm Paolo Mazzetti from the National Research Council of Italy, and I'm going to present the GEOSS platform and its potential contribution to the next GEOSS evolution. I'm presenting also on behalf of Joost van Bemmelen of ESA and all the participants in the GEOSS platform operation teams and working groups. In my presentation, I will provide a short introduction of the current status of the platform and propose some points of discussion about the potential contribution to the next GEOSS evolution. The GEOSS platform is the central component of the current realization of GEOSS, whose vision was described at the very beginning of GEO activities in 2005 as a system to support decision with timely Earth observation data and information. This vision identified the two main actors as the existing systems as resource providers and decision makers as resource end users. However, connecting them is a hard challenge due to the large gap between them. For decision makers, it's not easy to discover, access, process, and use the right data for decision among the many offerings. So the GEOSS platform aims at bridging this gap between providers and users, including not just end users, but also intermediate users, as for example, scientists or software developers, who typically provide the knowledge and tools for basing decision on Earth observation. And in doing this, it applies the so-called separation of concern pattern, which suggests to let the actors focus on their fields of expertise. For example, in this case, resource providers can focus on upstream services to publish quality data, while intermediate users can focus on downstream services, generating and visualizing the knowledge required by its decision makers. And in this picture, the GEOSS platform covers what is also called the midstream services layer, where actually made of those value-added services, including interoperability, harmonization, integration, that are necessary to facilitate the access to heterogeneous systems for different applications. But this central component can be actually realized according to different approaches, architectures, and technologies. There is only a governance constraint that actually this central component should implement a system of systems in order to let existing systems functioning and evolving according to their own mandates and governance arrangements. And this explains why the GEOSS infrastructure underwent many changes during the last 15 years to adapt to policy and technology landscape changes. So if we look at the GEOSS infrastructure history, we can identify some major milestones for this evolution. With the first one, of course, as the establishment of the Group on Earth Observation, with the mandate of building the GEOSS. Around 2008, the first GEOSS common infrastructure was released as a clearinghouse catalog that is a metadata repository, including information about the protocols supported to connect with the different provider systems, selected from a set of specification approved or under approval in GEOSS. And around 2010, a first GEOSS portal was released to query the clearinghouse catalog. In 2012, the Discovery and Access Broker was deployed as a new component of the GCI. It is a mediator directly connecting with existing systems. And this was actually a major change by a governance and architectural point of view, because adopting a mediation approach to complement the adoption of standards, GEO basically lowered the entry barrier to providers, since now most of the burden and effort to interoperability was moved from the providers to the GEO support and working groups. This actually required also to revise the portal, and a completely new, redesigned and developed GEOSS portal was released by ESA at the end of 2015. Finally, new components like GEOSS mirrors, GEOSS widgets, and application programming interfaces opened the GEOSS infrastructure capabilities to machine-to-machine interaction and to developers, making it a GEOSS platform. So basically, the GEOSS platform main components are the GEOSS portal, which is the general purpose user interface to GEOSS, and it is developed as a framework including reusable portal components, so-called GEOSS widgets, and also the capability to generate mirrors that are replicas of the portal for creating and tailored community portals. The Discovery Access Broker is the mediator, providing uniform access to heterogeneous resources. It also exposes application programming interface for machine-to-machine interaction, and it also implements GEOSS views that are the possibility to expose selected subsets of GEOSS resources for specific communities. The GeoStatus Checker is a component that monitors the status of remote data sources for checking availability, and is important in a distributed system. And the GEOSS Yellow Pages, which support the GeoProvider registration process. So to summarize some information about the operational GEOSS platform, we can say that it is nothing less and nothing more than an advanced data discovery and access system. Nothing less because actually it connects now almost 200 open data catalogs and information systems. What is interesting is that most of these sources provide also non-satellite datasets or mixed datasets, including both satellite and non-satellite. It actually gives access to something like 45 million dataset metadata fields with over 400 million granules. Of course, the granularity depends on the data source, so it is difficult to give a clear definition of datasets and granules, but the order of magnitude is the one showed in the slide. It supports more than 35 protocols and protocol profiles. It makes dataset accessible when made available by the providers. It provides advanced functionalities like views, bulk download, which is the possibility to download a set of data, and data transformations. It supports interaction with humans through GeoPortal or dedicated applications, and machines through application programming interface. It provides a configurable query result ranking. It collects usage statistics at portal and broker level, and it is deployed on an elastic cloud for high performances and high availability. But of course, there are some limitations. This is the reason why I say it is nothing more than a data discovery and access system. First of all, it currently supports only discovery and access of data. And we know that there are other important resources that are currently not supported, like documents, code, and so on. It has a limited semantic support. For example, discovery is based on keywords and also only on textual content of selected metadata fields like abstract, title. Ranking is configurable but based only on the metadata content. There is no link between resources, and basically it implements a discovery, download, processing, publishing pattern, which is not the best for big datasets, for example, for many satellite datasets. So what's next? What's the future? Of course, we can imagine a sustained operation and incremental innovation, which means brokering new sources, provide enhancements based on community requests. This is what it was done recently, for example, in the last 2 years, mostly through the European Commission Edge project support. 55 data sources were connected, with other 24 data sources updated. New functionalities were implemented on request of communities, like two-step queries, bulk download, the support of dedicated search fields like magnitude for earthquakes, sensor types, and so on. And the statistics collection was improved. And we can also imagine a radical innovation, and this should be done integrating solutions proposed and experimented by the Evolution Working Group. But what actually the GEOSS platform operation can also provide in terms of future development is a set of lessons learned, basically. One, for example, is the link with user communities, because while radical innovation can be suggested by changes in the policy and technological landscape, incremental innovation can greatly benefit from the user community feedback. And this is what happened during the work of the GEOSS platform operation. Another point is the mediation pattern, because GEO is a multidisciplinary initiative, and we know that different communities have their own standards and profiles for sharing resources. And GEOSS is what is called an acknowledged system of systems, not a directed system of systems, meaning that GEO cannot impose anything to providers. And providers would like generally sharing resources through GEOSS, but often cannot dedicate effort to that for financial, legal, or technical barriers. So mediation basically means that the GEO community put the most of the effort to connect with the providers. Another point is addressing intermediate users like developers and scientists who are typically proxies to the decision makers. We did this providing several ways to interact with the platform. For example, through standard service interfaces for system integration or direct connection with standard-based tools. We provide custom APIs for web mashup, supporting rapid and agile development, and also software libraries for developers who are not expert in geospatial technologies. Another important lesson learned is to consider that being a central component means that we can provide value-added service. We are a single point of access. There is the possibility to, for example, to harmonize resources, to pre-process them, and also to integrate and analyze them. So, in conclusion, the operational GEOSS platform provides an advanced discovery and access system with functionality to serve a great amount of Earth observation in situ datasets. And future developments can leverage the GEOSS platform experience, both in terms of capabilities, because of course we know that data are not sufficient, but data are still a fundamental component for the future evolution of GEOSS, and also in terms of lessons learned, like including governance, architecture, technologies. And the final remark, of course, the GEOSS platform operation team is interested in collaborating with all the other groups developing components or architecture technologies, like, for example, the activities in the regional GEOSS, the Geo Knowledge Hub development team, and so on, and all the other groups for the future evolution and development of GEOSS. That's all by my side. Thank you for the attention.